Alright, welcome to the ultimate guide to absolute value transformation. Now, in this very first one, I want to introduce y'all into the way that we just transform functions in Vertex form in general. So, we're going to call any new function that we have, we typically call it g of x, and what we say is it's equal to a f of x minus h plus k. And so let's just kind of go through these things. What is g of x? G of x just states, hey, this is what our new function is after transforming the original function, which means that this f, that single letter f, represents the original function, okay? And then you just have like these other various little aspects. This a tells you if you have a vertical stretch or compress. So let's just write vertical stretch slash compress, okay? And this x minus h tells us, is my function, my new function, going to shift left or right? Say shift left slash right. And lastly, this k value is going to tell me, hey, is the function going to go up or down? Now, I know that that's a lot to throw at you at once, so let's just kind of look at it in practice. Let's look at a couple of examples. And by the way, I would pause the video and just write all these notes down, because we're actually going to use this form of transformation through the end of the year. We're going to use it for absolute value transformations, for quadratic transformations, for square root transformations. In the next semester for logarithmic, exponential, any type of transformation, we're going to use this general formula. So I'd really write it down and try to learn these little elements right now. Now let's go ahead and put this into practice. Okay. So I took, it says if the function f of x equals the absolute value of x is changed to g of x equals 1/2 f of x minus 4 plus 6. Whatever this rule, that's what we're going to call it. We're going to call this the rule of transformation. Whatever this rule is, it really, the original function doesn't matter. The rule is always going to kind of tell us the same thing. So let's take a look at this 1/2. We know that this is our a value, and what you would say is that here 1/2, our a value is less than 1. So what does that tell me? Well, that tells me that I actually have what's called a vertical compress, or a vertical compression. And that means that my graph has been flattened out, thus it gets wider. Okay, so kind of shorthand, we could say, hey, this is wider. Okay, let's see the next thing. Inside the function, we have x minus 4, which means you always want to set that equal to 0. Now, what's the opposite of minus 4? Well, that's plus 4. So if x is equal to a positive 4, what that means is that our graph actually shifted to the right. It shifted to the right by 4 units, comma. And then here we have the last thing. We have this positive 6 on the outside of the function. And this positive 6 just simply tells us that we've gone up 6. So let's just go ahead and add that, up, comma, 6. So you can actually look at all these things practically speaking without ever having to write them. Now, this says our original function f of x, what we do is this. We write the new function g of x is equal to, and we leave a space here. We write whatever the function is here, in this case absolute value bars, and let's write x. We're going to leave a space, and then leave a space. And I want you to kind of identify this. We have the front of the function, inside the function, and outside the function. Well, in front of the function is our a value, so we just copy that down, 1/2. And then inside the function we have x minus 4, so our x minus 4. And then on the outside we have plus 6. So absolute value functions are really easy because the function themselves, actually look in general kind of just like the rule, and that's okay. Now, we know from our work here that our new function has a vertex. Let's see here. We said that it was going to shift to the right 4, so it's going to shift to the right 4, that's positive 4, comma, and it's going to shift up 6, and we know that our a value is equal to a positive 1/2. We can graph this. Let's say, hey, you know what? Here is the value of 4. Here is the value of 6. And then basically 1/2 is a vertical compression. So what we'll do is we'll draw a flatter graph opening up. All right? And that's just a quick, easy way to sketch it. I know this can be a lot, so let's go and do one more example together. Okay, so here we have our rule of transformation, and we see g of x is equal to negative 3f, there's our original function, of x plus 2 plus 3. Okay, let's go ahead and break these down one by one. Now here there's something a little bit new. Whenever you're talking about your rule, this negative is completely divorced from the 3. And this negative tells us that we are actually going to reflect across the x-axis. So over here, I'm perfectly okay if you just write reflect, comma, but you do have to understand you're reflecting across the x-axis. Now the next thing I would say is that when we look at this 3, my a value, remember we're divorcing it completely from that negative. We do not care about the negative. This 3 is greater than 1, and so we would say, hey, you know what, we actually have a vertical stretch, okay? Stretch. And a vertical stretch means our graph gets narrower. So let's just go and write that. We have a vertical stretch with the T coming first because we can spell. Okay. Now our next thing is we look at this x plus 2, and I have to ask myself, hey, if I set x plus 2 equal to 0, how can I get the x by itself? Well, minus 2. And x is equal to negative 2. So where are we going to go? If x is negative 2, have we moved to the right 2 or left 2? And we know we've gone to the left 2 because we're going in the negative x direction. Lastly, we have this positive 3. Positive 3 just tells us we're going to go up 3. Easy. Okay, so what is this function going to look like? Well, you take your original function that, and we write it as g of x is equal to, I leave a space, absolute value, x. Inside the function, I leave a space, and on the outside, I leave a space. Okay, what in the world is going to go in for my a value? And that's going to be negative 3. And what's going to go on the inside? Well, that's the plus 2, and on the outside, the plus 3. So we see that this function, once I transform it, looks incredibly similar to the rule. Okay? Just instead of writing the f, we actually show the actual absolute value bars for the brackets. Now from here, we should know everything we need. We should know that our vertex is at a value, remember our x value is negative 2, comma, positive 3, and our a value is equal to negative 3. So let's go to our vertex, negative 2, comma 3. I go to the left 1, 2, I go up 1, 2, 3, and there's my vertex. I know that due to that negative, this V shape is going to go down, and the 3 is greater than 1, so I should expect a narrower or a skinnier graph as it is vertically stretched. Alright, I hope that these two examples helped you out, and I'll catch y'all in our next video.